Light moves at about 186,000 miles every second, quick enough to circle Earth 7 times in the blink of an eye. Yet where we're headed, even that incredible speed begins to feel slow. As we depart from our solar system, the sun shrinks into the distance, turning into nothing more than another dim spark fading into the darkness of space. Our journey will carry us 9,500 light-years away from home, toward the constellation Scutum. Somewhere in that distant region lies a star so enormous, so unimaginably vast, that it challenges everything we think we know about the size a star can reach. We are traveling faster than any machine humanity has ever created, faster than Voyager, faster than every probe ever launched from Earth. At this speed, the entire solar system would be behind us almost instantly. We would reach Alpha Centauri, the nearest star system, in less than a second. But distances in space aren't measured the way we measure journeys on Earth. In the universe, distance is measured in light. With the technology we have today, reaching even the closest star would take thousands of years. Space is not simply empty. It is unimaginably vast, freezing, and difficult for the human mind to grasp. And we are crossing 9,500 light-years of it. The star known as UY Scuti isn't just far away. It's distant in a way that stretches human imagination. By the time the light we see from it finally reaches Earth, entire civilizations may have risen and fallen, languages may have appeared and disappeared, and still those same photons continue their long journey. And there it is, UY Scuti, appearing only as a faint orange point in the distance. But its true story is not just about distance. This star is unstable. It is approaching the end of its life. Its outer layers expand and contract, slowly releasing matter into space. This is a star performing its final act, and we are heading straight toward it. What you're about to witness will completely redefine the meaning of the word large. This is UY Scuti. At first glance, it might not look especially remarkable, but watch what happens if we place it at the center of our solar system. Earth would vanish instantly. Mars would be consumed. Even Jupiter would disappear inside it. The outer edge of this colossal star would stretch almost all the way to the orbit of Saturn. The scale is almost impossible to comprehend. For comparison, Earth is about 7,917 miles in diameter. The Sun measures roughly 864,000 miles across, large enough that more than 1 million Earths could fit inside it. But UY Scuti exists on a completely different level. If it replaced our Sun, its surface would extend far beyond the orbit of Jupiter. It is truly one of the most enormous stars known to exist. Yet being this massive comes with consequences. The larger the star, the faster it burns through its life. UY Scuti is already racing through its final stages of evolution. Within a few million years, a brief instant in cosmic terms, its core will collapse. When that moment arrives, the result could be a supernova of astonishing power, an explosion bright enough to outshine vast portions of our galaxy for a short time. When the brilliance finally fades, what remains will most likely be a neutron star, the incredibly dense core of what was once a giant. A black hole could form instead, though that outcome is considered less likely. What is certain is that the star will leave behind the remains of one of the universe's most dramatic events. And yet, around a much smaller star in a quiet region of this same galaxy, something remarkable once occurred. On a tiny planet invisible from this distance, atoms created long ago in ancient stellar explosions eventually learned how to think, to ask questions, and to measure the size of cosmic giants. One day, UY Scuti will disappear. Its light will fade from the sky. But somewhere, orbiting an ordinary star, life will continue looking upward, still searching the universe and wondering about its place within it. Thank you for watching.